Section 1.7 is on solving problems involving objects, and it should be composite objects, I think. Composite objects are objects that are comprised of two or more different shapes or different objects. So when you're calculating the surface area of the volume, you kind of got to consider the parts which make that whole object. So for example, the first one, a wheat grain silo is made out of aluminum. Determine the amount of wheat the silo can hold. So if you're looking at the amount of wheat the silo can hold, that would probably be a volume question. So assuming that you're filling it from the very bottom up to the very top, you would have to have the volume comprised of two parts. You would have the cylinder part, and you would have the half sphere part. So the first part there, the cylinder part, the volume for that would be pi r squared times height, because that's just basically a cylinder. And then the sphere would be half of 4/3 pi r cubed. So if we start filling in what we know that the radius is 12.3, so that would be 12.3 squared times the height is 32.1 meters, and then you've got a half times 4/3, which would be 4/6 or 2/3 if you want to do that. 2/3 pi times the radius would be 12.3 cubed. And 2/3, just to show you, a half times 4/3 is 4/6 or 2/3. That's where I'm getting that 2/3 from multiplying the half by the 4/3. So if we fill in our values for that, we have 12.3 squared times the pi times the 32.1. That's going to give you 15,256.8588 plus 12.3 cubed times the pi times the 2, and then divide your answer by 3. You get 3897.3907. So if you add those two parts up, you will get 2,256.8588 plus the 3,897.3907. I get 19,154.24953, so on. So that would be about 19,154, rounded off to the nearest meters cubed. So this would be basically a combination of the sphere, half sphere, and a cylinder. So if you're asked, it says the second question, it says assuming the floor is also constructed of aluminum, determine the amount of aluminum required to construct the solid. So that would be a surface area problem. So you would want surface area of this silo would be the floor area plus the lateral part. So just take the pieces that you're combining. So the lateral part of the cylinder, and then the half sphere with no bottom in it. So your floor would just be the pi r squared, because it's just going to be a circle. Your lateral part of the cylinder, if you're looking for surface area, would be the 2 pi r times the height, and the half a sphere would be half of the 4 pi r squared, and there's no bottom in it, so you just have to take the half of 4 pi r squared. No bottom in this, the sphere part, I mean. So this would be pi times the radius of the floor is going to be 12.3 squared. And then you've got the radius for the cylinder part would also be 12.3 times the height would be 32.1 plus half of 4 would be 2 pi, and again the radius for that sphere would also be 12.3. 12.3 squared, sorry, because pi r squared. So now we just work each part out. 12.3 squared times pi, 475.2916 plus 12.3 times 32.1 times pi times the 2 is 2,480.7901 plus 12.3 squared times pi times 2 would be 950.5831. So if we add all those together, 475.2916 plus 2,480.7901 plus the 950.5831. We get a total of 3,906.6648. So if we round that off to the nearest square meter, we would get 3907 meters squared. All right, so the second question is combined of a sphere and a cone. So this is determine the amount of ice cream the cone is capable of holding, assuming that the cone itself is filled with ice cream as well. So it's filled, packed solid right down through the cone, and then obviously the sphere part on top would be ice cream as well. So if we do this one, we would need to know the volume of this particular shape would include the volume of the half sphere plus the volume of a cone. So the half a sphere would be half of 4/3 pi r cubed plus, you would want the volume of the cone would be pi r squared times the height divided by 3. So this would give you a half times 4/3 again is going to give you 2/3 pi times the radius is going to be 5.2 cubed plus pi times 5.2 squared times the height is going to be 12.4 divided by 3. And that's going to give you 5.2 cubed times the pi times the 2, and then divide that by 3. You're going to get 294.487 plus, you've got the 5.2 squared times the 12.4 times the pi divided by 3 is going to give you 351.1211, 1212 if you round it off. And if you add those two parts together, you get 645.6098. So I'm going to round that off to one decimal place, and that would be 645.6. And it would be centimeters cubed, which every centimeters cubed is a milliliter, so that would be 645.6 milliliters. The surface area of the waffle cone Now, I'm assuming with the ice cream, so that's basically every outside surface of that shape. So you would have the surface area would be the half sphere, and the sphere would not have a bottom in it. And then the cone, and it would just be the lateral part of the cone, because we wouldn't want the circle bottom for it. So the lateral cone. So the half sphere would be a half of the 4 pi r squared again, because that's the formula for a sphere's surface area. And then the lateral part of the cone would be the pi r s part. Now we don't have the slant height, so we're going to have to do a little calculation over here first, because if this is 5.2, and this is the right angle, and this is 12.4, then we know that this here can be found using Pythagorean theorem. So that's going to be 5.2 squared plus 12.4 squared equals x squared. So 5.2 squared is 27.04 plus 12.4 is 153.76. So if you add that to the 27.04, you get 180.8. So x would be the square root of that. Sorry about that. So x would be the square root of that, which would be 13.4 if I round it off to 1 decimal place. So if I come back over here now, I need half 4 pi r squared, so I'm just going to, half of 4 is going to be 2. So I need 2 pi. R would be, in, if we go back, the radius was 5.2, was it? Yes, sure. There it is on the right triangle that I have there. So 2 pi times 5.2 all squared plus pi times the radius is 5.2 times the slant height is 13.4. I just calculated that. So 5.2 squared times pi times 2 is going to give you 169.8973, and then the pi times the 5.2 times the 13.4 is going to give you 218.906. 2, if you round it off, and then let's add those two together. You get 388.8035, which is approximately 388.8 centimeters squared. Is your answer. Okay, the next question says determine how much paint is needed to paint the outside of the composite structure shown and assume the structure is on the ground. So that would mean there'd be no bottom in it. So if we're looking for the paint, we would need surface area again, because we're talking about the outside surface you'd be painting. So that would be the lateral part of the cone. So I'm just going to write down lateral cone. And it would be, again, the lateral part of the cylinder. So the lateral part of the cone would be pi r s, and the lateral part of the cylinder would be 2 pi r times the height. Because that part of the formula, you wouldn't need the pi r squared part because we don't have a bottom in it, or the 2 pi r squareds. So again, we need the slant height. So if we know that this is this one here, if you know your Pythagorean triples, you should know that that slant height should be 10 meters, because 6 squared plus 8 squared gives you 100. So therefore, the square root of 100 is 10. So this would be pi times the radius is 6 times the slant height is 10 plus 2 times pi times the radius is 6 times the height is 7. If you don't know your Pythagorean triples, I should write the workings down there. That would just be, I got that from 6 squared plus 8 squared equals x squared. So x squared equals 100, and x would be 10, if you're wondering. But if you know the Pythagorean triples, you can just put the 10 in there right away. So 60 pi would give you 188.4955, so on, plus 2 pi times 6 times 7 is 263.8937 and more. And then if we add those together, 188.4955, add it to that, 263.8937, we get 452.3892, which is approximately, doesn't say what to round it to, so we'll just round to the nearest tenth, 452.4 meters squared, because it's surface area. Okay, and question number 4, you have to calculate the volume of the figure shown. So we have a pyramid in the top, and we have rectangular prism in the bottom. So volume would be the volume of the pyramid plus the rectangular prism. So the volume of the pyramid would be, just trying to, okay, so this would be, the base is a square base, so it would be 8 by 8. And we don't have the height of that pyramid, we need the height for the volume. So we would need to calculate the height. So the height would be, if we do our right angle from here, we would have, I'm just going to put h for height. So this one is a little bit trickier because we don't have the slant height either. But I can get the slant height. It looks like all those measures of all the triangles, they look like they're equilateral triangles, all those faces. So if I take off one of the faces, this is 8, this is 8, and this is 8, which means that this is a 60-degree angle. So we could figure out the slant height here. If we use trig, we could use trig to figure it out, because we could use sine of 60, because this would be a right angle. Sine of 60 is x over 8. And that would give you x equals 8 times the sine of 60. Sine 60. Make sure your calculator's in degree mode. So 8 sine 60 as a decimal would be about 6.928. So I'm going to round it up to just one decimal place, so 6.9. So if we have 6.9 for the slant height, then we can get, this is quite a bit of work actually, then we'd have to use 6.9 squared, because now we can concentrate on this height of the pyramid, and this is 6.9, and this is 8, not 8 would be 4, sorry, because we're 8 all the way across, so 4 there. So we'd have 6.9 squared equals h squared plus 4 squared. So 6.9 squared would be 47.61 equals h squared plus 16. So h squared would equal 47.61 take away 16, which is 31.61, and then we take the square root of that. And we get 5.622, so that's about 5.6. So if we go back with that information, all that we needed, the height was 5.6 we're going to use. So our pyramid then volume would be your base times your height times your area of your base, times your height divided by 2, right? Base times the height, area of the base, times the height divided by 3, plus the rectangular prism would be length times width times height. So the area of the base for the pyramid would be 8 times 8 times the height we just got was 5.6 over 3, and then you'd add that to 8 times 2. So that would give you 8 times 8 times 5.6 divided by 3, 119.466, so on, plus that would be 64 times 2, which would be 128. So if you add those together, you get 247.4666, so on. So that would give you, approximately to the nearest tenth, 247.5 meters cubed. And that's it, I think, for that section. That one was a little bit harder, but there are some extra practice examples there on pages 59 to 60 in your textbook that you can try.